Hey, how's it going? So this is the second stream of the day. I'm going to keep focusing on what I was working on this morning, which is trying to generalize the region that we're working on. So here's our stream. It's looking good. Throw that in the background so we could see if anyone tunes in. All right, then we've got our chat right there. Okay, actually, I'll try something new. I'll just put the chat right back in there. And then wonder how small we can make that. So, okay, so let's make that size. Um, is that good? I just want to be able to see if any viewers pop in. Okay, that should be good. Now let's go organize everything real quick. This we could put here. Um, that's not very interesting. Okay, and then our coding window we want here. Alright, cool. What's that mean? Encoding overloaded. I'm not sure what that means. Um, okay, then we have our Trello board. I'm gonna break that out, make it a little bit bigger. Okay. Trello board doesn't need to be so tall. That's fine. Yes, and then our coding. Back to the Trello or PowerPoint. Come on. All right, cool. Could throw our PowerPoint there. So now up on the PowerPoint is where we were last stuck. Um, oh yeah, and then snipping tool could kind of go wherever. And then our notes we could put over on the side. And that could cover up the ugly OBS Studio window. All right, so we're set up. Now, what do we want to do? I guess let's put this over here so we could still see it if we're in our coding window. Um, let's open up the Trello board and why is that there? Okay, cool. Um, so let's see what we're working on. So brainstorm ways to tweak analysis so that it's consistently profitable. Um, so what do we do for that? Um, varied number of years to go back. Now generalizing analysis to get now generalizing analysis to see if other shaped if differently shaped regions work better. Okay, cool. So what else do we have? Get optimization to consistently give the same results. Um, I'm gonna say this is the on the back burner for the now, on the back burner for now. 100 pop size. 100 was roughly the same as pop size 10, second attempt. So this doesn't really matter too much because we're using differential evolution, and there's some randomness to it. Now, all right, I'm gonna move that back over here. Change output to be, still need to do that. Fix plotting so that the saved plots look good. Still need to do that. Um, all right, now this is where we left off earlier. Um, optimize line location is optimizing for triangle region when I'm trying to work on rectangle region. So let's go ahead and run there. It's still in there. So we're failing the region test that we wrote. Oops. All right, we're failing the region test that we wrote. Now what line specifically is failing? In assess region. Perform optimization. Result equals analysis dot assess region. Get profit for the current season from the model. Assess region params. So we're passing in the wrong region params. All right, so what line is that? 197, 300 in perform optimizations, calls assess region, result equals analysis dot assess region params. So we print the region params, right? So it's just xint minus 278. So we have the wrong parameters. Region params equals blank. So for C param and enumerate params, region params of valid region types. So region params of valid region type. What? Back up there. So where do we define the what line? 134? Line 300 in perform optimizations. Result equals analysis dot assess region params. Region params is equal to optimize line location of training season's region type. So optimize line location is returning the wrong type of params. So we're returning best params. Best params is a blank dict here for param and data dot keys. If param is not equal to profit, then we're adding best params. So that means that best param data of param of mean. So for param and data dot keys. So the data the data isn't saving. The data isn't saving. Where's file name? Right. So the optimization data doesn't save right. So where does the optimization data save? Inside of the optimizable func. There it is. All right, I gotta go to the bathroom real quick. I'll be back in 2 seconds. All right. So we found where we're writing. So the problem is that when we're writing to the file, we're writing the wrong parameters to the file. Region params equal, for C param and enumerate params, region param of valid region types of region type of C. Now let's, um, we don't want to put it in optimizable func, but we do want to put it in, um, right above or right below? Okay, let's put it in right here and we'll start exploring there. So ST to put the debugger in. I've imported at the top from PDB import set trace as ST. So there we have our debugger. Now what's our region type? Triangle. Now, well, okay, that explains it. Why is region type triangle? All right, let's try putting it in up here and seeing what the region type that's passed in is. Continue. Rectangle region must contain params A, B. All right, let's run it again. Now it'll put us in right here in where it says optimize line location. Um, so what do we want to, we want to look at region type. So it's still triangle, so we know that we're okay there. Now what's wrong? So the one we're running is perform optimization analysis. That's down here. Perform optimizations. Oh, so we want to do test optimization. Well, there's our problem. So 0, then test optimization is equal to 1. Let's save it and let's see what it optimizes to. Continue. Now let's remember to take out the debugger line. Oops. Oh man. Shapely, invalid value encountered in contains. So that's where we're looking for the points in the region. Now, why did that happen? So shapely, invalid value encountered in contains. And it's hot here. I gotta go turn down the heat. All right, so why are we getting this error? Shapely, shapely, shapely. Oh, that's in double scalars. Now we have it in shapely. Huh. Now, did it do the whole optimization? Oh, it completed. Oh, all right. So let's go here. Optimization data. Let's go to today. Did I put the right date on the live stream? Yep, 12/13. Cool. Um, So back to here. Um, oh no, never mind. We're not looking for that error. No, we just want to see what's the plot look like. 224, yeah, just ran. Um, okay, well that's the wrong plot. 224. That's the triangle region. Optimize line location. Plot region, season equals seasons. Region type equals region type. Oh, okay, this is inside of there. So it will do analysis.plot region and it'll pass in the right region type. Um, okay, now let's do A. We'll intercept at minus 22.2. Let's do B. Intercept at minus 250, we could say. Um, region params, region type equals region type. So here let's say region type is equal to rectangle. All right. And let's run this file. See how it does. Oh, we don't even want to test that. We want to test region profit. No, test region plot. Yep, test region plot. So get that off of there. And let's test the region plot. So we also want to plot the rectangular region. Okay, and it does it, but it's pretty ugly. Why are there 4 lines is our question. So, oh, probably because the points aren't in order. That's gonna be my guess. Yep, so the points are in the wrong order. Okay, so point 1, so it does the A. So minus 10,000. I think we could just switch around this order. So it should be point 1, point 3, point 2, point 4. That should work, I think. And it didn't. Oh, that's better, but it crosses over. So it goes, all right, let's think this out. So point 1 will be, I see. So, this is hard. The 2 lines can be located anywhere. Let's actually No, we can do this. So let's figure this out. So we're gonna say if A, if if region params of A is greater than region params of B, all right, so if A is larger than B, then we're just going to want to change the order that we put the points in. So we have our points. It should be the same no matter, the points will always be the points. But if region params of A is greater than region params of B, region points. So if A is larger than B, then the top leftmost point would be this one, 0.1. Okay. Then the other point at the top would be 0.3. That's right. Then we would go to the point on the bottom. So that would be 0.4. The point on the bottom associated with B, and then we would go to the point on the bottom associated with A. Actually, I think that might be all we need to do. Let's just check. Oops, let's check that right here. Oops, what did I do? Okay. 1, 3, 4, 2. All right, now let's make sure that's saved and let's run it to see if it runs the right thing. And it looks good. All right. So this looks like the box we want. Now let's test to make sure it still works if B is larger than A. Or, let's test to do with the reverse. So now A is larger than B, so let's make B larger than A. Nice. So now we're taking all of these bets in this region. Okay. Cool. And let's just make sure this is a box. Yep. And up top, is it a box? Looks like it is. Yep. Okay, so plot region we know works for the rectangular region. Now, test region plot, test region profit, test optimization. Let's go back to test optimization. And when we're testing the optimization, so we know that plotting works, but remember this plot in here is the most recent optimization plot, and that's the wrong plot because it's giving the triangle parameters. So test optimization equals true. Now region type, oh. Region type should be rectangle. That's why it's giving the rectangle. That's why it's giving the triangular plot is because we gave it a triangular region. Bet return referenced before assignment. So we're back to this problem. I think that there are no points in the region. Assess region. Okay. Bet amount equals that. Now, for item and region wins. So we could say for item and region wins, bet return equals, and if np.isNan of item dot any is equal to false, do that, otherwise put the debugger in. So this returned false, meaning that none of them were nan. But then it says bet return referenced before assignment. If item for item in region wins. So for each item in region wins. All right, let's go print region wins then. All right, let's see what the region wins look like. Local variable bet return reference before assignment. So there are no region wins. So that's the problem. Is now if region bet return, where did the problem come from? Print item of -1 bet return profit, local variable bet return. Okay, for item and region losses. Huh, 223. That's our debugger line. Why doesn't it go to the debugger line? For item and region losses, we want to print bet return. But there is no bet return. Bet return is defined in the region wins loop. Region wins. Yeah, so we actually don't even care about printing that there. Cool. Yeah, so we do want to print, but we just want to look at the profit. All right, now let's run this again. If region, didn't mean to leave that there. Okay. Now let's run our script again. Lots of invalid value encountered in contains. Best x int. Okay, so this isn't referenced anymore. So let's take it out and try again. Just trying a lot of data frame. Damn it, again. Optimize line location. Oh, ax1.scatter. Right, so back to that, I forgot. We have to figure out how to deal with multiple values that we're plotting. So num subplots, there should be So that means there's two rows of subplots and one column. There is a way to, you could say there's two rows and two columns, and then one side takes up both column or both rows. So num subplots is equal to best params len of best params dot keys. So it's however many parameters there are, and then plus one for the main plot, then fig x1, x2. Okay, so then we could say fig subplot axes is equal to that. Then we could do for C axis in enumerate subplot axes. So let's enumerate each one of these axes, and for each one of the axes, if we're not dealing with the last axis, if C, let's see, so let's say Python 3, A is equal to 1, 2, 3, 4, for C, A, and for C item in enumerate A. Um, what are we trying to do? So we're gonna say if C print C is equal to len of A. Okay, so now let's do for that print C is equal to len of A minus 1. Okay, so if C is not equal to length of subplot axes minus 1. So if we're not dealing with the last, so if we're not dealing with the last subplot in the list, and last subplot is for the region wins/losses plot. So if we're not on the last plot, then what we're gonna do is subplot. All right, for C axis and enumerate subplot axes. If C is not equal to the length of the subplot axes, we want to say ax1 dot scatter. Oh, we're gonna say for C axis, so axis dot scatter. Okay, so for each one, then we're gonna want to scatter data of oh man, if plot equals true, then variable keys equal valid region types of okay, so that's already a list. So valid region types of region type, data of valid region types of region type of C. So get that variable. and we want to scatter that according to profit, I guess. Okay, gotta go to the bathroom again. All right, so um, where were we? So we want to go through each subplot axis. So for each one of those, we're going to want to scatter the variable versus the profit type. Um, okay, so let's get rid of that. Now we want to add in axis.setLabel. Axis.setXLabel. And the X label we want to just be valid region types of region type of C. Um, okay, then we want to set the Y label of the axis to be profit. Okay, then we're gonna say set the title of the axis. No, that's actually not necessary. Um, then separate data, then plot region. Seasons axis to plot on is equal to subplot axes of -1. Um, okay, so okay, let's think now. Man, okay, we have to figure out how to do matplotlib two subplots on one, or no, sorry, single subplot taking up two. All right, now, is that? No, that's, we could just find the example we want. Um, plot plt.subplots for row in AX or column in row. All right. Maybe we could just add a subplot on the end. I mean, this isn't going to look good, but let's just look at it real quick to see if it's giving what we want. Oops, don't want to run that. We want to run the test analysis. Sorry, test plot. Oh no, I don't want to do that. I wanted to test the optimization. Yeah, so I guess we have to do it with the second equation. Um, test optimization. Did I not save this? All right, and we'll see what the optimization does. Now, I'm hoping we can get this to work. While we're here, we may as well fix the saving of the plot so that it looks good. Huh. Now this is confusing. So yeah, we should change the bounds so that one is positive and one is negative. So they shouldn't be able to go all over. The bound should be from minus 5,000 to 0 for A, and then from 0 to 5,000 for B. That way they never cross over one another. Um, we'll say 0.1 so we don't end up with any so you don't end up with regions where it's saying both lines is one thing. That would break the shapely part of it. So we've changed the bounds. That should make the one look better, but we still only have one subplot for the parameters. We're trying to automatically generate a new subplot for each parameter. Okay. That's funny. So it just optimizes to take all the bets. Although the profit is still pretty insignificant. Oh, of course it does that. We don't want, these are the wrong bounds to use. We don't want one to be negative, we want one to be positive. I guess we want one to kind of move like between 0. I guess we want a short moving one. So let's test the plot analysis. Turn the plotting back on. Take off the optimization test. Turn on the region plot. And let's run it. Now we should get the plot and we could figure out a range of points we want to go through. So okay, we want to zoom in on the 0 area. Now we want the y-intercept. If we're looking at this data, the y-intercept should go from like 0 0 to around here. So it could be 0, it could be down here at minus 100, minus 150. So, how low, basically how low do we want? We want to separate the lines so that they're moving differently. So the first line should be go between like plus minus 50 or plus 100 to minus 100. Maybe plus 100 to minus 50. I mean, we're not going to want to cut out all that, to be honest. Oh, it minus 0. So here's minus 0. Um, yeah, minus 50 should be good for the top line. So minus 50 to say 300, the top line can go. Yeah, 100.